But you have to understand how to find the determinant, because this is what we are going to use in, I think, in November, maybe in December. And if you don't know how to find the determinant by the cofactors, it's going to be very difficult to get to the problems of optimization. Because problems of optimization is exactly when this topic is required. In August, we are going to have a 2 weeks or 3 weeks, I think it's 2 weeks course of mathematics for those who enter the program, and this is going to be a course of mathematical language and a little bit as a refresher for all those topics again. But I would recommend you to look at those topics well before, so that you will learn mostly English and mathematics rather than the mathematical concepts per se. Another problem, and probably the last one for today, is going to look something like that. If we have matrix P, which is equal to, no, that's not matrix X. We have some matrix X, which is m by n. So this is not the square matrix. And we have the matrix P, which is equal to x transposed x inverse x. This is so-called projection matrix, but it doesn't matter how it is called now. You have to show this identity. This property is called idempotence. But I would like to show you that this property is true, that P is equal to P squared.
The transpose sign on the last x, not on the first one.
The second one. And here.
No. Outside of the brackets.
Here, like this one.
Yes.
Maybe you're. Yeah, it's easier. So if we basically do this, x times x transpose x minus 1 times x transpose, and again times x transpose x to 1 times x transpose. Here's what we see. We see some matrix over here. We see some identity matrix over here. Which basically brings us to x times transpose x minus 1 times x transpose, which is p. This is it. Which softly brings us to the problems with matrix multiplications and all different operations with matrices. And all those different matrix rules that you have learned from the very beginning when you just started to look at the matrices. Such as A transpose B transpose is B A transpose, something like that. I will put a lot of those here because there are many of them. I'm not going to look for all of them. But again, look at the problems that demand you how to, not only how to calculate the matrices, but also how to operate with matrices in the letter form. Because there's going to be at least one problem on how to do that implicitly or explicitly in the exam. So the stuff that I covered today, I would think it is pretty basic. Maybe it is, it shows a little bit, it demands a little bit more than a regular course, but actually you have learned everything that I covered here today. Which means if you had some difficulties with some of those problems that I presented, you might just need a lot of practice, but the instruments for this, all the tools, you already have. So just get a bit more practice, and I think you should be fine with at least this part. Next month and the month after next, we're going to have 2 more lectures. One of them is going to be on calculus, and another is going to be on the theory of probability. And if you get prepared to those 2, it will be much easier to follow what I'm saying here at the board. Are there any questions, guys?
What are the dates of
It's on the website.